What we want to do in this video is learn how to graph the parent function of 1 over cosecant, which is the reciprocal function, which is secant. So we're going to go ahead and take the same approach as we did with the cosecant, which is let's first plot points from the cosine graph, and then let's just take all of these reciprocals and plot them down here. And then we'll just see how the graph looks, and then we'll go on to some other examples. All right, so what we want to do is let's just start with a few that we know from the first quadrant of the unit circle. So like say if we had 0, pi over 3, and pi over 2. Okay, and so if those are our theta, let's go and find our cosine then. So cosine of 0 is just 1, and I have the unit circle right here so that you can verify this. But yet again, these things should be memorized by using all the tricks that we learned about how to memorize the different values on the unit circle. Let's see. So cosine of pi over 3 is going to give us a half, and cosine of pi over 2 is going to be 0. Okay, so I have these two identities over here. One is that cosine is indeed an even function. If I plug in a negative theta, out pops a positive value. So that's just by definition of what an even function is. And so we're going to use that here in a minute. And we're also going to use this cofunction identity, which is if I take the cosine of theta and if I add pi to it, well, that's going to be the same thing as taking the cosine of theta, but it's opposite. I'm going to show you why this is a useful identity here. Okay, well, let's see here. Well, if this is cosine of pi over 3, then we know that if I were to take the cosine of negative pi over 3 using this identity, okay, look, if I plug in negative pi over 3 into here, well, the output's going to be the same as the positive value. So if this is 1/2, then this also has to be 1/2. All right? All right, so now that we kind of have these 4 values here, I'm going to use my cofunction identity, and I'm just going to add pi. So watch this. If I take negative pi over 3, and if I add pi, so pi plus negative pi over 3, let's see, that's going to give us a 2 pi over 3. Okay? So I just did this right here. Well, if I add pi to it, my output is going to be the same as the cosine value, just the opposite. Well, the same as the cosine value was 1/2, so I do the opposite of that. So it's going to be negative 1/2. And there we go. So we didn't really need to have this unit circle over here because this is the most important part, right? Which is the first quadrant. So all I did was I just took this and I added pi right there. Okay, so that's kind of what we're doing right now. So negative pi over 3 was right here. Okay, and if I add pi, bing, this is where I'm at. And if I take the cosine of that, that's where negative pi over negative 1/2 comes from. But we don't need to use the unit circle because we're using this identity. So watch this. If I add pi to this, so if I plug in 0 right here, 0 plus pi is pi. And this is telling me that it's going to be the same thing as cosine except the opposite. Well, the cosine value was 1, so the opposite of 1 is negative 1. This is awesome right here, man. This is super powerful. So let's just continue that pattern here. Pi over 3 plus pi is 4 pi over 3. And then I have to take the opposite of this, which was a 1/2, so it's going to be negative 1/2. Okay? I add pi to pi over 2, and I'm going to get 3 pi over 2. Let's see, 3 pi over 2. And the opposite of 0 is just 0. And I'm going to keep going until I get to one full period or one full cycle, okay? So now I'm going to add 2 pi over 3 plus pi is going to be 5 pi over 3. And the opposite of negative 1/2 is 1/2. And then if I add pi to pi, I get 2 pi. And I do the opposite of negative 1 is 1. All right, so cool little trick there. Now I'm going to go in and take these same theta values and plop them all down here, but I'm going to take the reciprocal of these guys because that's how we plot our secants. All right, so I'm going to do same thetas, except I'm going to take the reciprocal cosine values. So negative pi over 3, and then 2. Again, like I got 2 by doing the reciprocal of 1/2. I got 2 right there. So 0, reciprocal of 1 is just 1. Pi over 3, 2. Pi over 2, 0. 2 pi over 3, negative 2. Pi, negative 1. 4 pi over 3, negative 2. 3 pi over 2, 0. 5 pi over 3, 2. And lastly, 2 pi, and I get 1. Okay? Now, the reciprocal, I'm sorry, the reciprocal of 0 is like 0 over 1. So if I flip that, that means 0 is going to be in the denominator. So those should not be 0. Those should be undefined, right? So let me just make that correction real quick. And that's one of the neat things about this thing is that just like cosecant, we're going to have vertical asymptotes. So that should be undefined and undefined. All right, so here are all the points. It's not what I want to do right now. Just go ahead and plot all these guys so we can see what this graph looks like. All right, and so I'm going to kind of go over here, and this would be my negative pi over 3. Actually, let me do this real quick here. My increments are going to be pi over 2, pi, 3 pi over 2, and then 2 pi. So actually my stakes, I guess you can say, are going to be in increments of pi over 2. And let me show you why that I'm doing that. Because we just don't want to mark things anywhere because they just have to make mathematical sense. Meaning that if this is pi over 2, then pi over 3, well think about this. This would be like 1, 6, 2, 6, 3, 6, right? So we're going by 6 right here. So this would be like pi over 1 pi over 2, 2 pi over 2, 3 pi over 2. So right here, this is going to be our pi over 3. Okay, so this would be our pi over 3 right here. And I'm just going to do that, make my markings in all of them. So it should be 1, 2, hold on here, what's going on here? There should actually be 2 right there. Let me start that over again here. So I want to keep these markings right here. And let's try that again. Okay, let's see if this make a little more sense here. So I want to go by 6. So watch this. This is like 1 pi over 6, 2 pi over 6. Well, 2 over 6 is 1/3, right? Okay, and you can kind of think about the unit circle, right? Like all I'm doing is I'm doing this. Is I'm saying, okay, this is 0. So that's my first hash mark. That's my second hash mark, and then that's pi over 2. Okay, this is going to be my first hash mark, second hash mark, and then pi. So that's what these little marks mean right here. Okay, so like this is pi over 6, this is pi over 3, and then this is going to be pi over 2. Okay, so just kind of give you a visual here. These little circles are indicating the same thing that's on the hash marks. Okay, so that's where those are coming from. So bam, no. All right, so at negative pi over 3, so that's 1, 2, 3. So this is negative pi over 2. So this is pi over 6, pi over 3 over here, right? So we're going to have 2. So 1, 2, 1, 2. So I'm going to go right here, and I'm going to put a dot. I think I'm going to change my color here. So let's go right there. Okay. And then we're going to go 0, 1. And we're going to go to 0, and then we're going to go to 1. And then we're going to go to pi over 3, 2. Pi over 3, 2. And then we're going to have pi over 2 undefined. Go ahead and bust out my cool undefined little tool here. So look something like that there. I'm just going to go ahead and do my 3 pi over 2. 3 pi over 2 will look just like that over there. Kind of move this guy over. Ha, cool little tricks of the beans right there. All right, so we got those two guys. Let's go to 2 pi over 3, which is going to be right here. And then we're going to go down to 1, 2. And then we're going to go to pi, which is going to be negative 1. And then 4 pi over 3, which is going to be negative 2. Okay. And then we could go right here, 5 pi over 3, which is 2. 5 pi over 3, which is going to give us 2, and then 2 pi 1. So this is kind of like 2 periods and then plus a little bit here. So let's just go ahead and graph this guy. So we got that dude, and then we have this guy right here. Okay, so this right here would be 1 full period. Okay, so starting from negative pi over 2 to 3 pi over 2, that would be 1 full period. And then we have this extra guy right here. I mean, like, it's going to do the same pattern. So this would be like 1.5 periods right here. So I guess you can say a full complete pattern is going to be from negative pi over 2 all the way to 3 pi over 2. And we could also put in our vertical asymptote as here as well. Okay, so let's just review what we just learned. So here's what we just graphed right now. Okay, and notice once again that if you were to graph cosine, it starts at 0, 1, and it does this little guy right here. The maximums and the minimums of our cosine happens to be the max or mins of our secant right here. And so that's where we have our turning points at the maximums, and same thing right here at the minimum. So you actually may even want to graph the cosine graph just real quick if you want to make sure that your graph is correct, or just to kind of guide you in your graphing there. All right. And then these things are also true. The x-intercepts are going to be at every, I'm sorry, the domain's going to be all x values except at these vertical asymptotes, right? And so that's why it's going to be x equals pi over 2 plus n times pi, meaning it's all real numbers except at every increment of pi over 2, and where n is an integer. So like if n was 0, then we would be at pi over 2. If n was 1, then we would be at 3 pi over 2. And this thing just keeps going on over there. And the vertical asymptotes are the same thing that we had right there. And our range values is all the values except in between -1 and 1. Okay, so the key points, and again, this is only a half a period, are just taken from the table that we just had. Okay, and so that would be from negative pi over 2, negative pi over 3, 0 pi over 3, and what's that, pi over 2? And that'll give us an undefined 2, 1, 2, and undefined. So that just gives us this guy right here. But again, the reason why that these are just the 5 key points is all you do is you just take these points that we just had and we flip them, and then we just transfer them over. So that's why you could just go ahead and use by just knowing these points right here, 1, 2, and 3, that guy goes flipped over and then over pi. Flip that guy over and then over pi. Flip that guy over and then over pi. So this is why you only have to really know these 5 points. But if you did want to get the other points, we can use that really cool identity, which says that if you take negative pi over 2 and if I add pi, right? If I add pi to that, then that's how you get these extra values. Is you just keep adding pi to them, and then you're going to get your other values there.